Sathyabama Institute of Science and Technology.
Myself, Dr. M. Pushpavalli, working as an assistant professor in EEE Department, School of Electrical and Electronics, and today my presentation is about 8085 microprocessor. Microprocessor, according to the definition, it is an integrated chip which incorporates the function of a central processing unit, and mainly it is a multi-purpose silicon chip. It consisting of register based and clock driven. So when you go about the microprocessor consisting of arithmetic logical unit ALU, control unit, register array, and we can access through with input device as well as output device, and we can access through the memory devices, that is IO devices with the memory unit. Here in this particularly in this microprocessor, we are going to see about 8085 microprocessor. It is a Intel manufactured 8-bit microprocessor. And when you see about the basic feature of 8085 microprocessor, it is mainly used in the earlier computer systems and embedded systems. And when you see about that, it's a earlier computer system, so the speed is very less. Around the frequency is 3 megahertz. And when you go with that, it can have a memory of 64 kilobytes KB. Okay, and what are the components of the microprocessor? When you go with the components of the microprocessor, it consisting of ALU. What is the purpose of ALU? Na? It performs all arithmetic and logical operations, and it includes the control unit. Control unit can manage how the data should flow from memory to microprocessor or microprocessor to memory, as well as IO devices also. So 8085 microprocessor has consisting of set of registers, and these registers are programmed registers and which can be accessed by the programmer. So first we will see about the bus organization. So 8085 microprocessor, we have seen about all the working and all. Now we are seeing the bus organization. In the bus organization, it have a 3 buses: address bus, data bus and control bus. Address bus, when you go with that, it is a 8085 8-bit microprocessor. So the data bus length will be around 8-bit and address bus length will be 16-bit. So that address bus only decides the memory of the microprocessor. So 2 power 16, 16 is the address bus width. So 2 power 16 is nothing but 64 kilobytes. And data bus always carries the data between the microprocessor and memory or IO devices. Address bus is about to carry the address. So address means it is a unidirectional bus. It always carries the address, and data bus always carries the data. And apart from this 2 bus, one more bus is there, that is the control bus. The purpose of control bus is coordinating the data transfer operation. What are the coordinating data transfer operation? Read operation, write operation. What is read operation? Mainly it is the data is flow from memory to microprocessor, whether it is related to the memory. If it is IO devices, IO devices to microprocessor. Write microprocessor to memory, that is write operation. Then we have a hold. Hold means mainly requesting the use of address and data bus to the microprocessor is hold signal, and hold acknowledgement signal is also there. Then interrupt acknowledgement. If a processor want to do any other work apart from the normal flow of the program, we have to take the interrupt acknowledgement. And then data bus enable, address latch enable. This is another important control bus, mainly enables the address bus. So address bus, data bus and control bus are the 3 important bus organization of the 8085 microprocessor. So here we can see to that CPU in which how it is connected with the CPU interfaces, where I want to access my memory. EEPROM and RAM memory is there. If I want to access the IO devices, I have IO interface memory is there. So address and data, that is, we will multiplex the address and data, that I will tell you, and address bus and control bus. So these are the 3 bus organization of 8085 microprocessor. This is the pin diagram of 8085 microprocessor. It have a 40 pins, and mainly it is operate with the plus 5 volt, and we have seen that 64 kilobytes of memory is there, and the frequency is 3 megahertz. And this particular microprocessor can be grouped according to the signal. Okay, so 40 pins, the 40 pins are classified address and data bus having 16 pins, and a status signal, 3 signals are there: ALE, S0, S1, And control bus, it mainly perform three pins are there: read operation, write operation, whether I want to communicate with the IO devices or memory. Interrupt signals are there. Then clock signals, x1, x2 clock out to generation of the clock. And the reset signal is there. DMA, what is DMA na? Direct memory access, which having two pins, hold and HLDA. Then serial input output signals are also there, SID and SOD. Serial input data and serial output data. Then power supply signals, where processor needs supply and ground signal. Now we will see in detail. Okay, so address signal totally they are allocating 16 pins. So 16 pins na, here address buses 16 pins are there and data buses 8 pins are there. So what we will do, we will multiplex the address and data. Okay, so normally this bus always carries the, it's a group of digits carries the information. So what we will do, we will multiplex address and data. So D0 to D7, 8 bit is allocated for data bus, and A0 to A7 it is allocated for address bus. The remaining higher order address bus is there, A8 to A15. So here what we will do, we will multiplex AD0 to AD7. We are multiplexing address and data. That's why we will say AD0 to AD7, multiplexed address data bus, and the remaining address bus A8 to A15. So what we will do, we will multiplex and send. Then ALE signal we have seen na, this address latch enable. Whenever this signals become high, automatically it will enable the address bus and it will separate the address separately and data separately. That is the purpose of address latch enable. Apart from that, S0 and S1, that are the two status signal. The two status signals is two combination is there. So obviously 0001, 1011, 4 combination we can get it, and 4 combination is mainly for read operation, write operation, halt operation, opcode fetching operation. All this will be performed by S0 and S1. So this is address data signal and status signal. And the third one we will see about the control signal. So control signal, we have seen 3 pins: read, write, IO/memory. So read operation mainly for read memory to microprocessor, and write operation we have seen that microprocessor to memory, IO/memory. Actually IO/memory bar na, IO equal to 1 na, it mainly performs input output interfacing. IO/memory bar equal to 0 na, it obviously it will fetch the memory operation. 0 memory bar, 0 bar na, automatically the value will become 1. So we have seen 4 combinations: 00, 01, 10, 11. So here the first 3 indicates that 11, 10, 01. It is memory, mainly when you see with that 10 and 01, it is a memory read and memory write operation. Okay, and 10 and 01, IO read and IO write operation. So this Z indicates the high input impedance. So here when you see with this all this thing, first 3 indicates the memory bar equal to 0, memory operation, and next 3 indicates the IO/memory bar equal to 1 na, it perform input output operation, and the 00 always indicates the halt operation, and this Z indicates the high impedance, and x-axis is undefined. Interrupt signal. In the interrupt signal, what is the purpose of interrupt signal na? When the program executes automatically, when the microprocessor executing the program, some interrupt signal will come. Whether the microprocessor wants to attend that interrupt and all, it will send one interrupt acknowledge signal. So interrupt want to request the microprocessor, INTR signal will be there. Whether microprocessor is acknowledging that, that is we are having INTA bar. So this is for getting the permission, and automatically when microprocessor acknowledge that, it will send INTA bar signal. Apart from that, we have a 4 hardware interrupt: trap, RST 7.5, RST 6.5, RST 5.5. These 4 are the hardware interrupt, and we have a software interrupts also there. So hardware interrupt, the highest priority is for trap. Okay, when the trap signals comes, automatically it is a non-maskable interrupt. The microprocessor will pay attention to the trap. The next signals are, the next priority are RST 7.5, RST 6.5, RST 5.5. So this triggering level, whether it is a level based triggering or edge based triggering, that and all been mentioned in this table. Level and edge na trap, RST 7.45 for edge based, RSP 6.5 and 5.5 and INT are the level based. But the trap is the highest priority interrupt and it is a non-maskable interrupt. Non-maskable na the processor cannot able to mask the interrupt, that is the trap. Clock signals. Clock signals, we have a RC network connection to generate the clock. We have a X1, X2 to generate the clock, and clock output. Here we have seen the 3 megahertz is the frequency, so that will be get from the clock output signal. And then reset signal. We have a 2 reset signal, reset in, reset out. What is the purpose of reset in? Resets, mainly it resets the program counter to 0 and interrupt enable HLDA signal to 0, that is reset in. Reset output indicate CPUs being reset or it is a system reset, that is reset out. And one thing, the program counter is a register of the 8085. Then DMA signal. What is the full form of DMA? Direct memory access. Direct memory access, we have a 2 signal, hold and HLDA. Hold, this hold is when you see with that hold means the memory will ask the request to use the address and data bus. So once it asking the request to the microprocessor whether we can use the address and data bus, whether microprocessor accepting, it sends the hold acknowledgement. That means the microprocessor access the giving the permission or giving the acknowledgement to use the address and data bus directly without the intervention of microprocessor. Then the next signals are serial IO signals. Serial SID, serial input data, serial output data. So with the help of serial input data, RIM instruction, read interrupt mask is executed, and SOD, serial output data line is there. So this is for mainly to access the serial input output signal. SID and SOD is used. SID is used as an input signal and SOD used as a output signal. And power supply signal. And power supply signal, definitely processor needs supply 5 volt and ground. VSS is a ground and this VCC is a plus 5 volt. Then ready. Ready is mainly what is the purpose of this ready signals? It indicates memory or peripheral is ready to receive or send the data. So that will be acknowledged by the ready signal. So there are 40 pins are there. In the 40 pins, we are grouping into the 9 types of signals, and 9 types of signals, the mainly allocated signal will be address and data bus signal. Nearly we are allocating 16 pins to that. So there we are multiplexing the address and data. So 8 pins are allocated to that, AD0 to AD7. A8 to A15 will be the remaining 8 pins. So totally combining 16 pins are used. Apart from that, we have seen that power supply signal, serial signal, interrupt signals are there, control signals are there, DMA signals are there. So these are the other signals which is used for the microprocessor operation. So here, while we are discussing about 8-bit and 16-bit, mainly here we are using the hexadecimal number system. When you see about that, microprocessor will always use a assembly language programming. So in the assembly language programming, we used to say that assembly language programming as a mnemonics code. And in the mnemonics, each one, the assembler will convert that mnemonics code into hexadecimal code, and then hexadecimal code is converted into binary. So this is the operation where assembler play a role here. So in that, when you go with that hexadecimal number system, in the hexadecimal number system, we all know it is used from 0 to F, and we use the 8421 code to represent the hexadecimal number in a binary. So here we are using the mnemonics and assembly language program is a low level language. So 8-bit number system, we are saying 8-bit data bus, the data bit value will be, the minimum value is 00 and the maximum value is FF. So here I am having 1A now, I will write the 1 as a 001 according to the 8421 code. And A is nothing but we all know 10. So A can be represented as a 8421 code. Okay, and 16-bit number system. In the 16-bit number system also, we are representing all this by a 8421 code. So in 16-bit number system, we are having a minimum value as a 000 and maximum value as a FFF. F4 Fs will be used. So 8-bit 00 to FF and 16-bit 00000 to FFFF. 4 Fs will be used. These are the registers. Before entering into the architecture of 8085, we will see what are the basic register, because microprocessor consisting of assembly language unit, and we are say arithmetic logical unit, then when you see with that control unit, then register unit. So we will see what is the registers. Primary register is accumulator. The length of the 8085 microprocessor is 8-bit. So this accumulator length is also about 8-bit. Then it have a general purpose register. General purpose register na, we have B, C, D, E, H, L. Okay, so this can be used as a 8-bit register. When I combine B and C, it can be used as a 16-bit register. So these are the, what is the purpose now? It can be used for all programming execution and want to store any data or move the data and all, we will use. Program counter. Program counter na, program counter is a 16-bit address register. What is the purpose of program counter na? Program counter will hold always the address of the next instruction to be executed. That is program counter. Then stack pointer. Stack pointer is also 16-bit register. It always holds the address of the top of the stack memory. So if I want to perform any call program or interrupt program or any push and pop related operation, I will use the stack pointer. Flag register. Whenever the accumulator will have the data like depending on the 8-bit, whether I want to change the flow of the program, I will use the flag register. In that we have a 5 flags are there. Okay, carry flag, 0 flag, sign flag, parity flag and auxiliary carry flag. So 5 flags. Then memory. Memory we have seen it is a 16-bit address bus. So 2 power 16, 64 kilobytes will be used, and this is mainly used for storing the programming instructions as well as the data. So this is how the data is flowing from memory to microprocessor. These are the 4 important operation, how it is fetching the data, decoding, executing as well as storing. So here you look up this table 1000H, this is the address bus. Okay, the address bus, the memory is 1000H, and move B comma C, this is the mnemonics, and whenever we are giving the mnemonics, it is converted into hex code, that is we are saying that opcode, that is 41H. What is move B comma C? That means the C register content should be moved to B register content. We have already seen the general purpose register na, B, C, D, E, H and L. Here C register content is moved to B register. So here we are having 4 operation, how it is going to do with this instruction we are going to see. Fetch, decode, execute and store. Fetching. Fetching means program counter always hold the address of the next instruction. So what it will go? It will microprocessor fetch the address of the program counter, that is 1000. Okay, and in that what is the value in the 1000? That is 41H. In the 41H, the instruction will be, that is placed on the instruction register. Okay, in that instruction register, when it fetch the 41, then what the program counter will do now? It will increment the data. It will go to the next address. Okay, that is fetching operation. Then decoding operation. What is decoding operation? The control unit will decode the instruction in the IR. IR is instruction register. What is in the instruction register? 41. So what is 41? It will check. For the 41, the mnemonics will be move B comma C. That means I have to move my C register content to B register content. So first it is decoding. It is understanding the meaning of 41. Then it will go and execute. So execute means the control unit activate and it will execute the decode instruction. So what is the decoding instruction says now? Move the C register content to memory register. So the execute instruction will analyze whether the data is transferred between the registers or between the IO and memory, or IO or to microprocessor. All this data transfer, whether it is arithmetic and logical operation, everything will be analyzed by the control unit. According to that, control unit will perform and it will send the signal. We all know the control unit having all the kind of read operation, write operation, IO/memory bar operation, address latch enable operation, all this will be. So the control unit will decides and it will send the appropriate signal. What it's sending? It's sending the signal, I want to move the C register content to B register. So it will move. Then store, whether I want to store it in memory or I want to store it in a particular register, or it may be stored it in IO or accumulator, whatever may be, that is store will be executed. So this is the 4 data flow operation of the microprocessor. It is the detailed version of data flow from memory to microprocessor. So first AD0 to AD7 will be received from the program counter, and address latch enable will separate that A0 to A7, and then it is combined with the remaining address bit and it sends to the memory, and data bus is separately which will be in the memory, and then data bus will flow from memory to microprocessor. Instruction register will understand what is the operation, and then it will given to the decoding, and decoding will execute by the memory read operation, and in that memory read operation we are moving the C register content to B register. So this is the detailed version what we have seen in the previous slide. The C detailed version of the memory to microprocessor read operation is executed here. Then this is the architecture. So when you go with the architecture, whatever we have seen in the pin detail, that is given in the architecture. So this is address and data buffer, address bus. So we have seen it's a multiplex, and this is the address bus, and this is all about timing and control. Timing and control, we have seen clock generation, clock out, and read bar, write bar, ALE, S0, S1, IO/memory bar. These are the control and status signal. DMA, direct memory access, hold and HLDA signal. Reset, we have two signal, reset in bar, reset out. Okay, and supply +5 volt and ground. And accumulator is the primary register. Temporary register, the programmer cannot able to access the register. It will be stored in the internal of the microprocessor. Arithmetical logical unit, ALU. And flag register, we have seen that 5 flags are there. That will be depending on the ALU unit, whether I want to set the carry flag or parity flag will be decided by the answer in the accumulator. Then instruction register, okay, fetching the instruction. Instruction decoder, the instruction decoder will understand, decode and execute accordingly. Then serial control, SID and SOD. And these are the interrupt, INTR, INTA bar, interrupt request and interrupt acknowledgement. Apart from that, we have seen 4 hardware interrupts are the trap, RST 7.5, 6.5 and 5.5, and these are the registers array. Okay, W and Z, it's a temporary register, cannot access by the programmer. Program can access B, C, D, E, H, L. Okay, apart from that, we have a program counter, stack pointer. Okay, this is the register. So when you go with that, we have a address, memory, and then this all about the register, and this is a instruction which is to be executed and decoding, interrupt, serial output control. It's about whatever we have seen, the accumulator, register, ALU, flags. Flags, we will see about that. There are 5 flags are there. Carry flag, if any carry is generated, carry flag will become 1. Okay, if odd number of ones are there, parity flag will become 0. If even number of ones will be there, then odd parity bit will become 1. Auxiliary carry means nibble. Whenever the 4 bit we used to say nibble, if the carry is generated from 4th bit to 5th bit, auxiliary carry will be there. But this carry flags are mainly incorporated with the jumping instruction. So that primarily we will use 4 flags only, carry, parity, 0 flag. If my result is 0, 0 flag will be set, or else 0 flag will become 0. Here, when I am having my sign flag value is 0, it's a positive number, and sign flag is 1, it's a negative number. So control unit mainly understand how the signal will be generated. According to that, it will decode and it will work accordingly, whether the data has to be flow between the register or to memory to microprocessor or microprocessor to memory, or else with the IO devices. So these are about the 3 program counter, stack pointer and instruction decoder. So this all about, I have explained about the 8085 microprocessor along with the pin detail and the architecture. Thank you very much.